Hello students, once again welcome you to GK's Applied Maths classes. Today in continuation with the probability we are going to do normal distribution. Already we have done binomial distribution and Poisson distribution. Today we are going to do a normal distribution. I am going to give you introduction on normal distribution and also we'll try to solve some example problems from Cbse handbook. Okay. So let's straight away get inside this. This is the area table which we will be using. So we'll come to this later. Now, this is a normal distribution. Now, what is a normal distribution? What is the difference between Poisson distribution, binomial distribution, and normal distribution? Now, here we have a random variable x. Okay, a random variable x. It can be continuous or it can be discrete. So if the random variable is discrete and with certain conditions, the distribution is called binomial distribution or Poisson distribution. So if the distribution has to be binomial or it has to be Poisson, then the random variable x must be discrete. When I say discrete, it takes values like say 0, 1, 2, 3, 4 and so on, discrete values, okay, where you can say first number, second number, third number, fourth, fifth and sixth. If the random variable x is continuous, then you cannot do Poisson or binomial. It has to be categorized under normal distribution. So, if the random variable is discrete, you can have Poisson or binomial distribution based on certain conditions. If your random variable x is continuous, then the probability distribution that you have cannot be Poisson or it cannot be categorized as binomial. It will fall only under normal distribution. So that is one special case for continuous random variable. If x is a continuous random variable, like for example a continuous random variable like say height, weight, okay, where you have height as say 5.7, 6.3, you understand, or weight is like 43.4. So where you have infinite values between two distinct values. Okay, for example, if you have 5 and 6, you have infinite number of values in between this, where a person can have weight like 5.1, 5.01, 5.2, 5.02 and so on. Okay, so it's like if you have like 1, 2, 3, 4, 5, this is discrete. Because after 1 I jump to 2, after 2 I jump to 3, after 3 I jump to 4, after 4 I jump to 5. In this situation I can use sigma, where I can write sigma I equal to 1 to 5. When I say I, it means 1 plus 2 plus 3 plus 4 plus 5. Whereas when I say random variable is from 1 to 5, where I take all the values, I take all the values from 1 to 5, where I am not able to identify the number after 1, okay, and so on. So here there are infinite numbers, whereas here there is only 5 numbers. Okay, so this is continuous, this is discrete. When it is continuous, if you want to add, you can't use you can't use summation, you have to use integration. Okay, this is integral sign stands for summation. So if your random variable x is like this, then the probability distribution will be called a normal distribution. If your probability distribution is like this, like discrete, then it can be categorized as Poisson distribution or binomial distribution based on the conditions. Okay, that is the first thing that you should know. The second very important notion is, A continuous random variable x, okay, is defined in terms of PDF. PDF is called probability density function f of x. Okay, a continuous random variable x is defined by a probability density function called f of x. Now, how is f of x defined as? F of x is defined using this. Look at this formula. F of x is equal to 1 by sigma root of 2 pi e to the power of minus of x minus mu by sigma whole square. This derivation not required for us, so I am not going inside this. So this is how you define probability density function for a normal variable, okay, normal distribution. Probability density function is defined like this, where it has certain properties. The first property is f of x must be greater than or equal to 0. F of x is a positive function. F of x is always greater than or equal to 0 because f of x is an exponential function. You can see clearly it's an exponential function. So f of x is always greater than or equal to 0 for every x from minus infinity to plus infinity. Okay, that's very, very important. And please understand, a continuous random variable x, okay, is always associated with two things. One is called the mean, other one is called the standard deviation sigma. It has mean is mu. The mean is denoted by mu and the standard deviation is denoted by sigma. So a probability density function is always associated with mu and sigma. Okay. Now, when random variable, see, look at this very carefully. This is another very important thing. And it is also called normal distribution, or you can even call it Gaussian distribution. It's another name given to it. Okay. Gaussian distribution. So, first of all, the random variable x must be continuous. If it is continuous, then the probability distribution can be categorized as normal distribution or otherwise called Gaussian distribution. And for a random variable x which is continuous, I associate a probability density function called f of x. And how is f of x defined as? F of x is defined like this, and f of x is always associated with mean and standard deviation. Don't forget this. I am talking about only normal distribution. Okay. Now, this is how your function f of x looks like. Okay. It is called a bell-shaped curve. This is a normal distribution. It is a bell-shaped curve. Okay. In fact, I will draw it separately. It's going to be like this. Here it's not very clear. It's a bell-shaped curve. Okay. It's a bell-shaped curve. It will never intersect the axis. It's a bell-shaped curve. Okay. Now, most of the activity, most of the data activity happens around this point. And this is called the tail. Okay. The contribution of the tail is very, very less. So that is why they said less data at the ends. You have very less data at the ends. And most of the activity of the data occurs somewhere around this point. Okay. And this is the line. This is a very special line. This is the line of symmetry. At this particular line, you will have mean, median, and mode all are equal. Mean equal to, median equal to mode. Mean equal to, median equal to mode. And interestingly, for normal distribution, you will have only one mode, unimode. Okay, it will have only one mode. Okay, and this curve will never intersect the x-axis. So it is called asymptotes. Okay, it's called asymptote. So I hope you understand. This is your function f of x. So your f of x, okay, is a bell-shaped curve, symmetric about the line where the mean, median, and mode coincide. And most of the data cluttering happens around this point, around here. At the tail, less data is represented. Okay, That's very, very important that you should know. The next one is, see, I have told you this, mean, median and mode will be exactly same, okay, will be exactly same on this line. There is no difference between mean, median and mode. And you see a bell-shaped probability curve, and it has unique mode. I told you that, right? It's a bell-shaped curve and it will have only one mode. It will have a unique mode, okay? You know what a mode is, class 10th, okay? And the area, actually, when I'm talking about probability, in this case it is about area. Area from where to where? From minus infinity to plus infinity. Area from minus infinity to plus infinity, f of x dx. And you know, when you add the entire probability from minus infinity to plus infinity, the total probability is always equal to 1. That is what you got. Integral minus infinity to infinity, f of x is a probability density function. So total probability is always equal to 1. Okay. And not only that, I told you, right, this is a bell-shaped curve. This area, this is where you have your mean. Mean is represented by mu. This area will be half, and this area will be half. So the total area is 1. So this line x is equal to mu divides this bell-shaped curve into two equal areas, where the left side is 0.5 and the right side is also 0.5. Is it clear? Now, and of course there are some formulas. These are not required for us, so I will not go into that. Now, you have talked about, look at this. Is another very important thing I want to talk to you about. This is a normal distribution curve, y equal to f of x. Okay. Now, this is the line of symmetry where you have mu, where mu is the mean. At this line, mean, median and mode, no difference, it's exactly the same. In the exam, if they ask you what is the mode of a normal distribution, you can say mean is the mode of the normal distribution. Okay, now, I told you, right, most of the activity takes place around this area. That is mu minus sigma, mu plus sigma, where sigma is the standard deviation. So when I integrate from mu minus sigma to mu plus sigma, f of x dx, I am talking about area. Area bounded by this line and the curve is almost 68%. That is why we said lot of activity takes place in this region. You remember I told you? Here I told you, right? Data cluttered around the mean. How much it is cluttered? It is cluttered around 68%. From where? X minus mu minus sigma, mu plus sigma. Under that the area is 68%. Okay. Now, if I go little further, mu minus 2 sigma, mu plus 2 sigma, f of x dx. That is this blue red region plus the green region together. It will contribute 95% of the area. Or you can say the probability is 0.68. Here the probability is 0.95. You know the total probability is 1. Total probability is 1. Now for mu minus 2 sigma, mu plus 2 sigma only, the area contribution is 95%. Now just see this. If I go still further, actually this region, can you see this? This is actually mu minus 3 sigma and this is mu plus 3 sigma. So integral mu minus 3 sigma, mu plus 3 sigma, f of x dx, the area contribution is around 99.7%. So this red region, green region, blue region put together will give you 99.7% of the probability. So the remaining, the tail, you see the tail, its contribution is only 0.3 on either side. 0.3 by 2 on this side, 0.3 by 2 on the other side. That is why in this table, it is very beautifully explained. Less data at the ends, data is cluttered somewhere in the middle, and this is a normal distribution curve, and this is the line where the axis of symmetry, that is where the mean is the axis of symmetry. Okay. Now, if I look at this, if I have a look at this and I put if I look at this and if I put mu equal to 0, if I put mu equal to 0 and if I take my standard deviation as 1, if I put mu is 0 and standard deviation is 1, what will happen to this? This will become 0. Then 0 minus 1 will be minus 1. This will be plus 1. This will be minus 2. This will be plus 2 and so on. Can you see it? That's what I got here. You see, in this case, mu equal to 0, sigma equal to 1. Here you put mu equal to 0, sigma equal to 1. When you put mu equal to 0, sigma equal to 1, you get this curve where mu is 0 and mu minus sigma will be minus 1. That's what I got. And mu plus sigma will be plus 1. And then mu minus 2 sigma, mu plus 2 sigma. Mu minus 3 sigma, mu plus 3 sigma. I don't go beyond 3 because my area contribution is around 99.7%, only from minus 3 to plus 3. Isn't it? That's what we did here. Remember? From mu minus 3 sigma to mu plus 3 sigma, my area is around 99.7%. After that, the contribution is very, very minimal, so I ignore it. Okay. So here if you put mu as 0 and sigma as 1, you get minus 3 to 3. So between minus 3 to 3, my maximum probability will be 0.997, which is almost done. And the remaining is 0.003 that will be contributed by both the ends. Okay. So that is why we don't have a table beyond 3. We have only till 3 and minus 3. Not only that, when mu is 0 and sigma is 1, then the normal distribution is no longer called normal distribution. You call it standard normal distribution. So when will a normal distribution become a standard normal distribution? The normal distribution becomes a standard normal distribution when mu equal to 0 and sigma is 1. It is called standardization. Okay. What exactly happens? See, in real life, okay, if you have two set of data where your data set, your mean is 50 and standard deviation is say 3, and you have another data set where your mean is 100 and your standard deviation is 5. How do I compare both the two data sets? How do I compare it? It becomes difficult. So how do I standardize it? I standardize it by putting it under standard normal distribution by introducing a z-score. Okay? The z-score is defined by z equal to x minus mu by sigma. Okay? Where x is called the data point. X is the data point and z is the z-score. Okay? So basically what we do, we are finding the area. Look at this. Look at the table. See, this is how you find the area. Okay. Here, see, the area's contribution is very less. Only till 3 you will get good contribution. After that it will decrease. You see. So with that introduction, we'll start with the problems. So what is a quick summary? Let me have a quick summary of normal distribution. This is the axis of symmetry and it is symmetric about the mean. Okay. This is mu minus sigma, this is mu plus sigma. Mu minus 2 sigma, mu plus 2 sigma. Mu minus 3 sigma, mu plus 3 sigma. And the area correspondingly I have told you. Between mu minus sigma and mu plus sigma it is 6.8, 68%. Between mu minus 2 sigma and mu plus 2 sigma it is 95%. Between mu minus 3 sigma and mu plus 3 sigma it is 99.7%. Okay. And I have also told you what probability density function is, how it is defined as, and I have given you the formula. And you know the total area is 1, and the bell-shaped curve is divided into 2 parts. Each area is 0.5. Okay. So let's start with the problems. How do I do? Calculate the z-score for the normal distribution. This is example 17 from the Cbse handbook. Calculate the z-score of normal distribution of length of 7 rare species of Indian butterflies that you have in your garden. Okay. So let us see how to go about it. Now first of all, I have the butterflies. So this is like 1, 2, 3, 4, 5, 6, 7, and I have the length. The length of the butterfly is 2, 2, 3, 2, 5, 1, and 6 is the length of the butterfly. Now I want to find the mean. How do I find the mean? The mean formula is sigma xi by n. So what is sigma xi? Add all of them. If you add all of them, I get 21. Sigma xi. This is your xi. And what's the total number of data? Total number of data is 7. So what is my mean? My mean is 3. Mu is 3. Now I need to find standard deviation. So what is standard deviation formula? Square root of sigma xi minus mu the whole square by n. You have studied this in class 11th also. This is nothing but I want to find xi minus mu by sigma. Let us see. This is xi minus mu the whole square. How do I go about it? Xi is this. 2 minus 3 minus 1. Minus 1 square is 1. This is also 1. 3 minus 3 is 0. Okay. And then this is again 1. 5 minus 3 is 2, whole square is 4. 1 minus 3 is minus 2. Minus 2 whole square is 4. 6 minus 3 is 3. 3 square is 9. If I take the total of all this, I am getting 20. Root of 20 divided by 7. Root of 20 divided by 7, if I calculate, I am getting approximately 2.86, and the square root is approximately equal to 1.69. 1.69. Is that clear? Now, I need to find what I want to find. I want to find the z-score. Now, how do I find the z-score? You know, z is nothing but x minus mu by sigma, correct? So, what is z? X minus mu is what? Mu is 3 divided by sigma. Sigma is 1.69. And when we calculate this, I am getting it as minus 0.59. Now please understand, when your data point is x, when your data point is less than the mean, you will always get a negative z-score. Okay. Again, it will be the same, right? 1 minus 3 by 1.69, it is minus 0.59. Now when it is 0, what happens? 0 minus 3 divided by 1.69, which is what? 0 minus, this will be around, I am getting it as this is what? Xi. No, sorry. This is 3. I made a mistake. It is 3 minus 3 by 1.69, so it is 0. Here also I made a mistake, it's actually 2. I got confused with this value, it is actually 2, right? Xi. Then again it is 2 minus 3 by 1.69, which is minus 0.59. Now I go to 5. This is 5 minus 3 by 1.69, which is 2 by 1.69. I am getting 2 by 1.69 is, I think I am getting 1.18. 1.8. Okay. Then again this is 1 minus 3 by 1.69, which is minus 2 by 1.69, which is minus 1.18. Correct? And the last one is 6 minus 3 by 1.69 is 3 by 1.69, which is roughly I'm getting it as 1.78. 1.78. So I have found the Z value. That is what is asking me to find. Find the Z score of the normal distribution. So I have found the Z score. To find the Z score, what I find first? First I find the mean, then I find the standard deviation. How did I find the mean? I use the formula sigma xi by n. How did I find standard deviation? I use the formula sigma xi by minus mu the whole square by n. I use this formula because my mean is a integer. Okay, otherwise we would have used some other formula. I hope this is clear to you. Okay. Now the next question is example 18. Given that the mean here in the previous problem mean is not given, you have to calculate, but here mean is already given to you. What is the mean? Mean is 12 and your standard deviation is 4. Okay, mean is 12 and standard deviation is 4. Now the question is to find the Z score of the data point 2. So data point is 20. I want to find the Z score. So what is Z equal to? X minus mu by sigma. X is 20, mu is 12, sigma is 4. So it is 8 by 4. Therefore Z equal to 2. This is my first subdivision. Okay. So my first subdivision is clear. What is my second subdivision? My second subdivision, data point, I have to find the data point if my Z score is 5. What is the formula? Z equal to x minus mu by sigma. My Z score is 5. I need to find the data point x minus 12 by 4. So I get 20 equal to x minus 12. So what is x is equal to? X is equal to 32. So this is my data point 32 for the Z score as 5. Now what's the third subdivision? I want to find the data point if the Z score is negative. Okay. So if Z equal to minus 2, what is the formula? Minus 2 equal to x minus mu by sigma. Sigma is what? Sigma is 4. So minus 8 equal to x minus 12. So x is equal to 4. Okay. I hope this is clear. Very, very simple. Just using the formula Z equal to x minus mu by sigma. All that you should know is Z score means Z, data point means x. Okay. Don't forget that. Now let's go to the next question. This is example 19. In a district, exam scores of 300 students of class 12 are recorded at the end of the session. Are recorded at the end of the session. Just a second. Are recorded at the end of the session. Ramesh scored 800 marks in total out of 1000. The average score for the batch was 700 and the standard deviation was calculated as 180. Okay. So he has given mean is 700 and the standard deviation is 180. Find out how much Ramesh scored compared to his batch mates in the whole district. That is my first subdivision. Okay. How much Ramesh scored? Ramesh scored 800 out of 1000. So I want to find, when X is 800, what is my Z score is. Okay. Let us find what the Z score is. Ramesh scored, okay, Z equal to X minus mu by sigma. So Z equal to 800 minus 700 by 180. So this is 100 by 180. What is 100 by 180? 100 by 180 is roughly, I am getting it as 0.56. 0.56. Now Ramesh scored 800 marks in total out of 1000. So that means he has not scored more than that. So less than or equal to 800. So when X is 800, my Z will be 0.56. 0.56. Now how do I understand this? Now this is the normal distribution table. This is where my mu is 0. So 0.56 will be somewhere here. 0.56. When you want Z less than 0.56, that means I want to find the area of this region. Correct? Now how do I find that? I go to the table. Look at the table. I look at this table. Look at this, less than. What is the 0.56? So go to 0.5. I want to find 0.56, right? Go to 0.5, look at 0.5 and look at 6. 0.56, that is 0.7123. Is that clear? 0.56. Look at 0.5 here and 0.06 here. It is 0.7123. 0.7123. So it will be this will be 0.7123, correct? 0.7123. Now I want to convert it to percentage. This is 71.23%. So this area is 71.23%. Okay. So Ramesh, find out how much Ramesh scored compared to his batch mates in the whole class. What is it? Ramesh did better than 71.23% of the student. So he falls into this category. Is that clear? Well, you scored 800. You scored 800. So all the other students are below that. So you did better than 71.23 students. Okay. Because Ramesh is here. He has scored exactly 800. Okay. Now this is subdivision A. This is subdivision B. Let's see subdivision B. What happens? Sudha scored 420 marks in the batch. What can you say about her performance as compared to the batch of 300 students? Okay. So here a score is 420. So what is the Z score? 420 minus mean is 700. Standard deviation is 180. So when we calculate this, I am getting minus 1.56. Minus 1.56. So I want to know how many are there below 420. She has scored 420. I want to know how many percentage of students are there below 420. So that is P of Z less than minus 1.56. So from the data point, I go to the area. Okay. Now, if I have to represent this on a diagram, look at this. This is mu. This is 0, right? So minus 1.56 will be somewhere here. Minus 1.56. So this is the area I need to find. So definitely the answer will be less than 0.5. We'll check that. If I go to the table, look at this table. What is it? Minus 1.56. Look at this. Minus 1.5 is here. Minus 1.5. Minus 1.5. 6 is somewhere here, right? So minus 1.5 and 6, which is 0.0594. Which is 0.0594. So it's very less, right? So if I have to calculate the percentage, what happens? It is 5.94% if I have to multiply it by 100. So Sudha did better than what? Better than 5.94% of the student. She has done worse than Ramesh, but because Ramesh is far ahead, 71.23, because his score is very close to mean. The mean is 700. He has got little above mean, whereas this person got very, very less than the mean. You see, it is 700 is the mean, but she got only 420. So definitely her performance is not good. If they ask you to compare Ramesh and Sudha, just I'm saying. Okay. Now the next part of the question is little interesting. Let me take this question. This is the question. Let me have the question with me. How much Abe scored if he has done better than 43.83% of his batchmate? 43.83% of his batchmate, right? So that means I want to know, here it is given less than or equal to Z1 is 44.83%. Here the area is given to you. 44.83%, that is the area that is given to you, which is roughly 0.4483. We have Z less than or equal to Z1. Okay. So now what I should do is go to the Z table and look into it. Go to the Z table. What is the value? Just keep a track of this value, 4483. 4483. Look at this. You have to look inside the area. 0.4483 is here, which is minus 0.13. Okay, which is Z1 is minus 0.13. This is a Z, but I want to find the corresponding X value. So Z1 equal to X minus mu by sigma. Now what is Z1? Minus 0.13. And what is X? I don't know. What is mu? Mu is 700. Sigma is 180. Now when we cross multiply and calculate, I am getting X is equal to 676.6, which is approximately equal to 677. So Abe scored approximately 677 marks in the exam. Yes or no? How much did Abe score? So here, if he has done, they have told him, they have given in the question that he has done 44.83% better than others. Okay. So from there, what I do, area is given. From there, I find my Z score. Once I get the Z score, I get the data point X. Once I get the data point X, that is the marks that he has scored. Okay. Okay. This is the last problem. With that I will stop. Okay, with the example. Given the score of set of candidates, given that the score of set of candidates on an IQ test are normally distributed. If the IQ test has a mean 100, the mean is 100 and the standard deviation is 10, what is the probability that the candidate takes test will score between 90 and 110? So I want to know what is the probability of getting score between 90 and 110. Between 90 and 110. Now please understand here, whether you put equal to or not equal to, it's not going to make any difference because it is integration. Okay. So when I say integral 90 to 110, you can include 90, not include 90. You can include 110, not include 110. So don't worry about it. Okay. So now, when X is 90, what is Z? X minus mu by sigma, 90 minus 100 by 10, which is minus 1. Now you take X is 110, which is 110 minus 100 by 10, which is 1. So to find this, what I need to find is I need to find minus 1 less than or equal to Z less than or equal to 1. Okay. Now if I have to represent this on a diagram, this is where you have 0. So this is minus 1 to plus 1. So this is the area I need to find. So in order to do that, what I will do, first I will find the area less than 1. I find this full area, that is P of Z less than or equal to 1. That gives you this full area. Minus, what I will do, I will minus this area. I will minus this area. So what is that? P of Z less than or equal to minus 1. Understood? So this full area, that is from minus infinity to 1 minus infinity to minus 1. That will give you this region. Okay. So immediately I go back to the table. Okay. So when it is 1, what happens? For 1 it is 0.8413. Can you see it? 0.8413. Let's go back to that. This is 0.8413 minus. When it is minus 1, what happens? I think you can look into the table. It's not difficult. 1587. So when you subtract, you get 0.6826. So this is what we need to find. Isn't it easy? Okay. So this area, this is the area, this is the probability. What is the probability? The candidate, the probability that you will score between 90 and 110 will be 0.6826. Okay. With that, I finished all the example problems in Cbse Handbook. Next class, I will do exercise problems from Cbse Handbook on normal distribution. With that, normal probability from Cbse Handbook will be completed. Kindly subscribe to my channel and also click the bell icon to get the notifications of videos. I hope these videos are very useful to you. Need to be very careful with the calculation when you're doing applied maths. See you again in the next class. Have a lovely day. Bye-bye.